Statistics is a branch of mathematics that deals with the collection, analysis, interpretation, and presentation of masses of numerical data. Okay? Or you can call it a collection of quantitative data. Now, the difference between quantitative and qualitative. Quantitative data is dealing with numbers. So qualitative data is data that deals with quality of things. So you can talk about emotions. You could do like research on people's emotional states or opinions or feelings or perceptions. Those are qualitative. Quantitative data can be assigned a number. So even if you'd said, like, you guys have taken those, you know, how likely are you to take this class again, 1 through 5 kind of things, that can be quantitative. So you can even take a feeling and make it quantitative by assigning a scale. And that's what statistics does, is it analyzes that quantitative data. It is also the practice or science of collecting and analyzing numerical data in large quantities, especially for the purpose of inferring proportions in a whole from those in a representative sample. So when you talk about like the presidential candidates' percentages of how likely they are to get elected. Anyway, what they do, they don't ask, guys, they don't ask every single person in the United States, who are you voting for? They do not. They ask a representative sample of some large number of people from different geographical areas that will represent the entire nation, and then they take those numbers and like hypothesize that the whole rest of the population is fitting this pattern. That's statistics allows us to do that through random sampling and things like that. Now, probability. We're going to start with probabilities. Probabilities is how likely something is to happen. Okay? When you talk about the chance of rain, you know, 30% chance of rain today, that means there's a 30% probability that it will rain. There's a 70% probability that it won't rain. You know, they say, ooh, the chance of rain is really high today. It's 30%. That's not high. The chance of rain in Florida is like 90% every day. But we're talking like, I know they never say that, but in my head, it's Florida, it's summer, it's the afternoon, it's going to rain. But the probability is the likelihood that something's going to happen, and we express it as a ratio or as a percent. So we also have statistics. Probability falls under statistics, but it's the statistics that's only between the range of 0 and 1. And we're going to talk about that, but if there's a 0 probability of something happening, that means it's not going to happen. Okay, very few things have a 0 probability. But I will tell you one thing that has a 0 probability, and that is the probability that I'm going to sprout wings and fly out that window in the next 10 minutes is 0. Well, we'll see if I was right in 10 minutes, okay? Now, if a probability is 1, that's 100%. That means it is for sure going to happen, okay? So the probability that I'm going to breathe in this sentence is 1. Look, I breathed. See? It happened, 100% chance. Okay, so probabilities fall between 0, which is absolutely no chance, and 1, which is 100% chance. Okay? I can say with almost perfect certainty that the probability that I'm going to run into something and trip today is 1. Yeah, there you go. See? Already happened. Venn diagram is a graphic organizer. All it is it's a way to take information and put it in a picture format so you can look at it quickly and analyze it quickly without having to do calculations, really. It organizes things in a way. Now, if you go to our statistics book on Canvas and you go to page 2 of chapter 1, there are 3 videos available that are made by, I believe, Khan Academy and then some other people. So there's 3 different videos on Venn diagrams, so that if my explanation's not making a lot of sense, there's 3 more videos that you can watch through our book, if you want to. But, okay. In probability, a Venn diagram is a graphic organizer. The square or rectangle is the whole universe of possible existences. Okay? That is our sample space. So it's called the sample space. It's also called the universe, depending on whether you're in statistics or whether you're in like number theory or liberal arts math. In those areas, it's called the universe. In statistics, it's called the sample space. It's the same thing. It's just a different way of calling it. And then A and B are the ovals that represent the possible outcomes. Okay? In this section here, like this sort of moon, the yellow, this is A only. So that's that outcome, A only. And then in this section over here, you have B only. And then that overlap is A and B. So when you have a Venn diagram, you can throw things into those different spaces. Anything out here is not A or B. So that's why a Venn diagram is nice, because it allows you to look at a picture really quickly and see like how much stuff is in each section, and you can analyze it fast. So 2 coins are tossed, one right after the other. Event A is the outcomes when tossing heads in the first coin, and event B consists of outcomes when tossing heads on the second coin. We're going to draw a Venn diagram to represent that sample. Okay, so what are our possibilities? Our possibilities is the sample space. Okay? So we're flipping 2 coins, right? We can do a head-head. We're going to do a head-tails. We can do a tails-heads. And we can do a tails-tails. That's the only possible things that we can't do like a heads 5, because it's a coin, right? So we have 4 possible outcomes to this sample space. Now A is heads on the first toss. These will be A, heads on the first toss. And B is heads on the second toss. So this one and this one would be B, heads on the second toss. And we look here, this one doesn't fall into either of those. So when we draw our Venn diagram, we have our sample space, which is S, which is the universe of all possible outcomes. And then we have the A, which is the heads on the first toss, and we have B, which is heads on the second toss. The 2 tails has to be out here in the universe because it's not A or B. This one here, 2 heads, it's in A and it's in B, right? So that's going to be right here in the middle for A and B. And then we have heads, tails, and tails, heads. That is the Venn diagram of a 2-coin toss. Thank you. I tried. B. Event A is randomly choosing a student from the high school who has a part-time job. So A is part-time job. And B is honor roll. And we want to draw a Venn diagram to represent this example. No, it doesn't give you any numbers or anything, but we can still draw a Venn diagram. What we have right here is we have part-time job, have honor roll. And I bet you there are going to be some students that are both. So you have an overlap. Okay. And then out here, you have no job, not on honor roll. Okay. So that represents that situation. We don't have any numbers to put in, but we can see that there's an overlap. Now, sometimes we could have a situation where we'd have to draw a picture that's representative of a sample with no overlap. When that happens, you just draw your circles apart from each other. So if there were no students that were on honor roll and had a part-time job, you would draw the two circles apart. But right now, we don't know any numbers, so we draw them together. Now this area here might be empty when we actually do the experiment, but since we don't know, we overlap. If you know for a fact that they don't overlap, you draw the circles apart. Okay? Any questions on that? Quite close. Okay. The upside down U represents an intersection. It is represented by the word and it is the overlap, or the part that the sets have in common. So in our school student example, it would be the people that were on honor roll and had a part-time job. Okay. This U is for union. It is represented by the word or, and the union is the total of everything together, or all sets together. So in our other example, it would be every student that had a part-time job, every student that was on the honor roll. And that would include, of course, the students that were both. But it would be all of them. And it would not include the students that weren't on honor roll or didn't have jobs. It would just be all the honor roll students and all the part-time job students, and you put them together. It's kind of like a union is like a marriage. So you bring all your stuff, and now it's all together. A union is like an old-fashioned marriage, where you have all your stuff and you bring it, and now it's all together. No prenupts or any of this weirdness that is modern. 1800s marriage. All my stuff, all your stuff, now it's together. Okay, that's a union. So it's the same thing mathematically. We take everything in the one set, everything in the other set, and now we count them all. So if we have event A is a 1, a 2, or a 3. And event B is a 3, a 4, or a 5. Okay. And I want to draw a Venn diagram. And this is my sample space S, and I have my A, and I have my B. They don't have to be pretty. A is 1, 2, and 3, but B also has a 3, so I have a 1 and a 2 and a 3. And over here I have a 4 and a 5. And what number am I missing from a dice? 6. Okay. The intersection, A intersect B, that's the part that overlaps. So it's this football thingy in the middle. If you draw the circles nicely, it's the football shape. It's really pretty, but I don't draw them nicely, so. A union B is both sets all together. So it's 1, 2, 3, 4, and 5. We don't have to count the 3 twice. We only count it 1 time. So union, you take all of it and put it together. Intersection, you only take that part that overlaps in the middle. All right. Our sample space is the numbers 1 through 10. So S is 1, 2, 3. You get the idea. Okay. Event A is choosing the odd numbers. So event A is the odd numbers. And event B is choosing the prime numbers. Wait. Is 1 prime? 1 is not prime because a prime number is a factor of 1 and itself. But the number 1 only has 1 factor, which actually makes it technically not prime either. 2, 3, 5, and 7. Yeah, no, it's very close. Now, for our purposes in this level of math, if you put a 1 in there and said that 1 was prime, I'm not going to count off on that. Okay, but technically speaking, 1 is not prime. Okay? So, here is our Venn diagram. We've got A, which is 1, 3, 5, 7, and 9, and we have B, which is 2, 3, 5, and 7. 3, 5, and 7 overlap. So that's going to go in the middle. And then A, I have a 1 and a 9 left. And B, I have a 2 left. But look at these numbers. 4, 6, 8, and 10 didn't get used. So they go out here. Okay. A intersect B is the guys in the middle. That's a 7. And A union B is everybody in the circles. Oops, 2, 3, 5, 7, and 9. Okay, so the unions are both circles, basically. You ignore everybody out here. Nobody wants them. Okay? That is your first section. In your packet, let me...